Hello everyone. In this video I'm going to talk about the solution for some probability questions in Excel files which Utku Hoca uploaded to Blackboard. I will solve only one Excel file that has two questions in this video, and other videos will go like that. Shall we start? I will try to keep the video not long too much. A company has 16 consultants to distribute to three different projects, with 4 consultants for project 1, 5 consultants for project 2, and 4 consultants for project 3. In how many ways this can be done? Firstly, I need to check what I have. 16 consultants I have. Consultants. 3 different projects. 4 consultants to work on project 1, 5 consultants to work on project 2, and 4 other consultants to work on project 3. I need to use combination to select. But firstly, we need to pay attention here. How many consultants will work on 3 projects at total? It's 13, right? But I have 16 consultants. So, firstly, I need to select these 13 consultants from these 16 consultants. Combination is the operation to calculate how many ways anything can be done, any operation, any event can be done. And to calculate the choosing 13 people from 16 consultants, it's the combination of these numbers. 16 chooses 13 times. I need to multiple all of the selections in this question, because choosing 13 people from 16 consultants and choosing 4 people from 13 and choosing for also project 2 and 3, all of the selections, all of the choices are happening at the same time. So I need to multiple. Scale also. Scale is a better word. I have 13 consultants to work on projects, and I need to choose 4 of them for project 1. I already chosen 4 consultants for project 1 from 13, so I have 9 consultants remain to work other projects, and I will choose 5 of them for project 2. At the final, I have 4 other consultants remain, and I will choose 4 of the 4 for project 3. That's the data. It's a large number equals 50,450,400. That's the possible ways to compute that, calculate it. Other part, one of the consultants, say Ahmed, wants to be involved in project 3. What's the probability for that? When I select a special thing for a special case, like choosing only one person, that's Ahmed, for project 3, I need to select Ahmed first. And from 16 consultants, there are only one Ahmed from these 16 consultants, and choosing one person, that's only one, there's only one Ahmed, and I am choosing him, so I have only one ways to choose Ahmed. But that's shown like that with combination. 1 chooses 1. It's already 1 times. I have selected Ahmed, so I have 15 other consultants to select for other projects. And I need to choose 12 of 15. Why 12? I have chosen 13 from 16 in that part, but in that part it's 12 from 15 because I need 13 persons to be involved on projects. One of them is Ahmed, and 12 consultants are remained. 15 chooses 12 to work on projects times 12 chooses 4 for project 1 times 8 other consultants remained. 8 chooses 5 for project 2 times 3 other consultants are remained. 3 chooses 3 for project 3. Why I am choosing only 3 while it's written 4 here? Because Ahmed is the one of the consultants who will be involved in project 3 and I already chosen Ahmed, so I need to choose 3 other consultants. That's the favorable outcomes and I am supposed to find the probability. That's the possible outcomes that I've already calculated in the first part. So 16 chooses 13, 13 chooses 4, 9 chooses 5, 4 chooses 4. That's it. And it's 0.25. That's how to solve first question. I'm passing to second in the same exam file right now. I will also try to edit the questions on the screen. If I can't do that, I might share the link of the files if my teacher permits me. Okay. Second question. A production operation consists of 8 operations in 2 stations, 5 in station 1 and 3 in station 2. The operations in each station can be performed in any order, but all operations of station 1 must be finished before the starting any operation in station 2. How many ways can the assembly operation be performed? Check what I have again. 8 operations. 8 operations, 2 stations, 1 and 2. 5 operations in station 1, 3 operations in station 2. Firstly, I will try to explain it with combination instead of using factorial directly. That's the processes of a production. 5 processes in station 1. 5 operations also. The order is not important. At real, it will be important, but it's not important for that question. So, I have 5 operations and I need to choose one. How many possible operations I can choose for here? First process of the operations, first operation from 5 other operations. It's 5 chooses 1 times. That's equal to 5. 4 other operations to choose. 4 chooses 1, secondly. Then 3 other operations are remain to choose. 3 chooses 1, first, second, third. And 2 chooses 1 and 1 chooses 1. 5 times 4 times 3 times 2 times 1, that's equal 5 factorial for station 1. And for station 2, it's the same. 3 operations, I can assemble them in 3 factorial difference rates, that's equal to 6. And I need to multiple this because these selections are happening at the same time. Firstly, these need to be finished and this starts. I mean, they are happening at the same production, same time as this. That's equal to 720 possible ways. Second question, we have operation soldering. And soldering is the operation that's assembled in station 1. And I need to ask to find the probability that soldering comes second or third. Okay. I will draw it again. Soldering. I need to get soldering here or here. So it's S, not 5. If I get soldering here, how many possible ways I can choose an operation to here? It was 5 and 4 operations are remained. 4 chooses 1 and 3 are remained. 3 chooses 1 times 2 chooses 1 times 1 chooses 1. It's 4 factorial. Soldering is already chosen for second and others are chosen randomly. It's 4 factorial, right? And for second station, I have 3 operations and I am selecting 3 operations like that, like at first part. So 3 factorial. That's the how many ways I can assemble soldering in these operations, in that production. Or also soldering might come at third. That's the same result again, because I have 4 chooses 1 to calculate possible ways for here, and 3 chooses 1, and 2 chooses 1, and 1 chooses 1. And also, after the first station, for second station, I can calculate it in 3 factorial ways. Third factorial, 4 factorial times 3 factorial. It's OR. It's OR. So, OR means it's OR. This might be happen, either this might be happen. So, the possible ways to compute with OR is adding them. I need to add them. That's equal 2 times 4 factorial times 3 factorial, because it's OR, not AND, not happening at the same time. That might be happen, another time that might be happen, so I have that possible ways, 2 factorial, 2 times 4 factorial times 3 factorial. That's the possible ways. That's 5 favorable outcomes. How many possible outcomes I can assemble all of the 8 operations, like in that conditions written, given at the question. That's it. So the probability is favorable outcomes over possible outcomes. That's gone, and that's 2 over 5, which is 0.40. That's it. I also can calculate it by computing the probability of that soldering comes second and that soldering comes third, and total them, add them to each other, and I will get that result again. That's all for that video. Thanks for watching. Have a success in the exam.